Hi girls. So, what is annoying is it's nearly dark. It's too dark for me to not have the light on, but the light is right behind this. So I'm hoping you'll be able to see what I write up here. So I did two a question two. If there's any problems with that, come back to me. Let me know. I'll be online at the time. What time are we on it tomorrow? Let me just think. 10. No, 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 no. It's the one before lunch, the one after lunch. So I'll be available around that time, okay? I might do one. I'm going to get you to do three, but I might do one of three because I have a feeling you might look and say, these look a bit harder. So I might do one of three and then plow on and do another one. So I pick one of three, and this is now on page 70. I'm just going to try pick a hard one of three. Let's say I do the last one of three. Yeah. So the last one of three is integrate. Sorry, it's VI. And it's integrate 1 over x squared. My x's overlap like that. Okay. Minus x over root x. And around that has your dx. Okay. So let us start by getting it ready to be integrated. A bit like differentiation, you have to. Right now I can't integrate that with the fraction bit, that with the square root bit, that with the fraction bit. So we have to use index rules, and I'll write that up again. I'm just trying to remember. I think index rules are on page 21. I don't have my formula book. I don't have any of my books because I left them on school. But I think they're there. Anyway, so what I'm going to do, I'm just checking. I hope you can see this okay. For the first part, oh yeah, if you're given one like this, we're going to do these two bits separately, okay? So I'm going to be integrating this bit and then integrating that bit, okay? So the first one, leave your integration sign up because you're not integrating yet. But I'm going to turn this into x to the power minus 2. Hope that makes sense. That's that rule. If it's positive here, you can bring it up if it becomes negative. And this I'm going to change into x. Now, this is x. I'll do it in two steps. This is x over x to the power of a half. Sorry, I hope you can see that that's a half. Square root x, x to the power of a half, okay? It's still not ready to be integrated because there's this going on, something over itself. So what you can do with this, in fact, I'm just thinking out loud, how you could get around this is you could actually go about simplifying this using your index rules. So leave your x to minus 2. And over here, these are the same bases, they're both x's, and you're dividing. So what do you do with the powers? You take them away. So that would be minus x to the power of 1 minus a half would give you what? 1 take away a half, you'd be left with a half, wouldn't you? Okay, so now I can integrate this. But to here, I haven't done any integration yet. I've just been using the index rules to get it ready to be integrated. Mic that properly? Okay, so let's integrate the first one. So x to the power minus 2, increase the power by 1. So it'll be x to the power minus 1, and then divide by your new power minus 1. You know the plus c, by the way, I'll put it at the end. Put it over here so we don't forget it, okay? This bit here, if you increase that power by 1, it'll be a half plus 1, which will be x to the power of 1.5, which is 3 over 2. And this is actually a similar one to the last one, over 3 over 2. Okay, and I'll bring my plus C over. Now, if I straighten this up a little bit, and when I mean straighten it up, is these are actually both, just the one I pick is really like both of the previous ones. But anyway, this here, if I was to tidy this up then, we don't want to give it back with minuses and stuff like that, this would actually become, it would be a minus just to start. That divided by minus 1 would make the whole thing a minus. So I'll just write that like that. I'll come back and I'll finish it off in a second. Over here, this will be minus x. Now, I'm going to give it back as they gave it to me. So they gave it to me with a root in it. They didn't give me any fractional powers. So I'm going to give it back. So it's that same rule, and I'm going to write the rule here. A to the power of p over q equals, the q goes in here, the a is your base number, and your p goes there. Okay, so I'm going to apply that here, and I'm so sorry. I'm going to write it down a little bit further. So that's, what did I say? That's minus x to the power minus 1. Here then, this will be minus, so this will become x to the power of, no, it's x to the power 3 over 2. It's going to become root. Now, the q goes in there, the p goes up there. So the 2 goes in here, and the 3 goes up here. Okay? And it's divided by 3 over 2. And as I said in the last one, that's the same as times and by 2 over 3. So actually, I'm going to do it in one move. There's your minus. I'm going to put a 2 over 3 plus c. Okay, I'm not finished, but I'm almost there. I'm going to turn this into a positive power by doing it like this. 1 over x to the power of 1. I'm not putting it in, but we've done that a few times. And then this is minus 2 over 3. And then square root of x cubed plus c. Okay, so that's one of question 3 done out. If you can now try more of question 3, first have 2 done, and then try more of question 3. And then I'm just looking here. I can help you with more of these, but I'm looking. Question 4 says find y in terms of x for each of these. What they're asking you there, they're giving you the derivative, the dy dx. They want you to find the y, and you do that by doing this process of integration. So do 4 as well. Let me just see. Yeah, do 2, do 3, do 4, and you can give 5 and 6 a shot if you want and continue on. Let's see how far we get on these. Communicate with me and let me know where you're at. But because this first part of this is really important to get your head around what you're doing. And do you know what sometimes can be confusing is that people get confused between am I differentiating and am I integrating? So it's important to know at the moment we're doing the opposite of differentiation. Okay, any questions? Let me know. Now,